robotics. So today I'm going to cover the four remaining technologies: IoT, that means the Internet of Things, augmented reality and virtual reality, cloud computing, and blockchain. So these are the contents of today's session. Okay, let's start with the Internet of Things, IoT. Now, this is a technology that is very much related to artificial intelligence. Right? It's very much related to artificial intelligence. Actually, it's a kind of a supporting tool for artificial intelligence, right? Supporting tool for artificial intelligence. So that means the artificial intelligence is data driven. So we need data, right? So we need text, images, numbers, and all kinds of data. So the AI systems are data dependent, right? So therefore, the AI is data driven. The IoT is a kind of a tool or a concept or a framework or paradigm that can help AI to acquire data, right? So to acquire data, from diverse fields, right? From diverse fields to healthcare, to agriculture, transportation, education, for many other disciplines, Internet of Things or IoT can help to bring that data into the system. So now you are about to start a degree in science. So this IoT plays a very important role in science because we work with scientific instruments where the instruments are very advanced, complicated, and for maintenance, right? We can use the various sensors and collect data, and we can analyze it through some kind of a central interface. So if you consider an example, say from science, say subject like, uh, you know, biodiversity conservation or something like that, some of the biology students will learn these kind of things. Now, this is an important area, even in Sri Lanka, right? The biodiversity, starting from uh, the tree, the forest, right? Where is ecological improvement, components, and then we have the various animals, right? The animals are there, right? uh, Elephants, right? It's a big uh, you know story, with the elephants, right? All these all the components with regards to you know biodiversity, could be there. And and by conservation, what I mean is the management. I mean the managing of these things, right? And so what we can do is, in terms of managing, that means if you consider, plants, right? Particular plant, we can monitor now. Most of these areas, the accessing for normal people is complicated. We need, some specialists to go into these areas and, make the uh, place safe, right? All the biodiversity management. So what we can do is, we can, plug in various sensors to, these, right? Even, we can have a kind of a drone or something, running on top of, right, the area, taking pictures. And, we can have, sonar or, sound, detectors, we can have, various, kind of, audio recorders or, uh, right, audio or sound, recorders. So that could help, taking various data, right? Drone taking, pictures, right? And, even we can use devices such as, GPSs, right? And even we can go to the extent where we can have some kind of wearable devices, right? Over here. If, such kind of, sensors can be placed, right? We can, place various sensors and get data, and then all the data can be sent to a central kind of a, platform, right? Data can be sent through the internet, of course, right? Through the internet, we can send it to the internet, and to a central interface, to be, running in some kind of a server or something, right? The central, uh, management interface, can, analyze the data, right? This could have, various apps, right? So various apps, models, right? And we can have artificial intelligence over here, and, these apps and tools can, perform various predictions, in terms of the health of these plants, right? This is a sensor, uh, you know, to check, soil condition, the water, right? Uh, we can also use computer vision like technologies, and then we can, um, make an efficient, system to manage conservation of this, biodiversity. It's very important, and it's a need in Sri Lanka also now. The elephant issues going out there in Sri Lanka. This, issues related to monkeys and all those things are there, and this technology can be used, effectively, to, handle these things. So we can use predictive analytics, and then we can make decisions based on that. So this is one example of, using IoT. And in terms of the sensors, we can, think about biosensors also. uh, Biosensors are, special kind of, devices that can collect data from, humans, animals. They can, measure even the glucose levels, right? Go into the, blood, and collect data, right? Measure, you know, glucose levels, nutrients, right? Etc. Can be, measured. So we can use, this kind of a system to make this biodiversity conservation effective using IoT. So this is An example IoT system, right? And now IoT means Internet of Things, right? Internet of Things. So the term things here, what do you mean by things, right? So things are now, look at this elephant, wearing some kind of a, gadget on his one of his legs, and then the elephant actually becomes a thing, right? It becomes a thing over here, right? And this particular plant also a thing, right? And uh, like that. Now Internet of Things, so that is what we mean by things. So to call something a thing, it should have for example kind of a sensor, but it's not limited to sensors only. We can use various imaging technologies also these days. And so this is an example of an IoT system. So these things can be extended to any area of science. It could be a chemistry lab, right? Chemistry lab, we can, in terms of the, very special scientific instruments in a chemistry lab to, measure various chemical properties. Usually, these advanced machines already contain some, sensors, and through the sensors we can manage uh, remotely, right? So some of these machines are manufactured or distributed, from USA, right? Even from USA, we can, do the maintenance using these IoT systems that are included in those machines. And for example, cars, nowadays, most of the cars are, full of sensors, right? Are full of sensors, and we can, use this the data coming from the sensors regarding the engine and various other parts of the vehicle, and from that data we can make decisions regarding its maintenance. So that is the IoT, such an important area in technology, right? So this is kind of a definition that I can give you. Is a network of physical object or things, right? So things now, that elephant, trees, like that, embedded with sensors. Now these things are embedded with sensors. So that is the most important part of this, IoT systems, right? Embedded with sensors, and then we should have software. Now, in that example, I was talking about the central interface. We have these apps, right? Actually, these are software. These are software. And other technologies, for example, I was talking about the computer vision. We take images from the drones, right? And analyze those images and make, you know, some decisions now. And also we can use sound, such a, a scenario where maybe managing elephants, the other animals, we can depend on the sounds, right? As well, and the other technologies for connecting and exchanging data with the other devices via the internet. So this is the other important component of an IoT system, right? So we must need internet. So that's why we call it Internet of Things, IoT, right? And some examples. So this is from agriculture. You can see that most of the state-of-the-art IoT, based, you know, systems. If you consider, agriculture is one of them, right? Agriculture, even in Sri Lanka, people use sensors to get data. right? Some examples are there. We can use auto-spreading diagnosis of diseases. So this is really crucial, right? In a big farm like this, which is extremely complicated to find these diseases by humans. So we can use sensors and we can use imaging devices to take pictures and then process them and detect the disease, right? Crop yield analysis, okay, soil erosion, we can use sensors and do, and field monitoring, the water stress levels, variable rate of fertility, and all those things. And we can gather all data and we can manage through a central interface like this. So therefore, the use of IoT in agriculture is very important application, right? And then I have presented two applications from transportation and shipping, and this is an example where a taxi system. Now this is all these cars are taxi, right? Some taxi service, and these taxis are embedded with sensors, and we can collect data from these taxis, and then send it to a IoT interface, and then we can use for scheduling, right? Efficient scheduling, and even the maintenance, right? Even the maintenance related things, and tracking. These kind of operations can be performed through the use of sensors. And this is another example where we use in a truck like this with various sensors to track the assets, right? Where for theft detection, we can identify whether there are any theft happening, when especially in shipping or delivery, cargo environmental condition, fuel levels, geolocation, vehicle speed, and idle time. Now these kind of things are very important. Now these are some delivery vehicles, right? We need to manage efficiently to make more profits for these shipping companies or any other factories. So even measuring the idle times are quite important. Geolocation, the GPS. We can collect data and manage through IoT frameworks, right? So let's look at some examples out there in the internet. Okay, and some of the things that you see. Just look at let's look at some kind of a small video clip, and um, so this is an example.
Softanji has been successfully
Well,
operating
some
in the
actually
global market for
this is
25
kind of an
years,
advertisement, but still a lot
specializing in
of
digital
things are there.
transformation consulting. With a modern digital style creating
And
success
these people
automation.
are
How does
managing
it
these
work?
kind of vehicle
Trackers
fleets,
installed in a vehicle
right?
determine their location and speed using
And
GPS GLONASS receiver.
they use uh, you know GPS and these kind of GLONASS receivers to
And
get
transmit
data
via
from these
GSM
vehicles,
communication to the server.
right?
GPS tracker is able to use additional analog and digital sensors to control engine speed, its temperature, vehicle
And
accident,
these
and
things
other
actually happening in the
characteristics.
world. I mean,
In addition, the tracker can connect to the vehicle's
and we
onboard
can
computer.
manipulate this even through a mobile interface, right? You know, now this could be a CEO of the company, and he can log into his phone app and check what is happening with this vehicle fleet, and where this vehicle, that vehicle. So how effective can that be, right?
These data can be accessed by your employees via web
Right.
or
So these
mobile
kind of
application.
technologies
Access rights to collected
can be
information
used,
and
right?
generated reports. The fuel sensors are
Fuel
installed in the
sensors,
vehicle tank to monitor fuel. Our equipment has a high degree of protection from external factors and fault tolerant hours,
right?
track completed trips, and detect violated operations.
And
And color, depending on
then
the state
we
of your
can do
asset.
see these kind of analytics, right? So we can do these kind of analytics from a remote interface, and then we can manage. So that can be a really, really important technology, even in the Sri Lankan context, and also in your degree program. Maybe your final year research project, right? I mean, even if you do not follow computer science as a subject over here, all other subjects, right? Botany, zoology, chemistry, physics, physics, very especially in physics, right? Computational physics. You have to work with these big machines and experimental setups, and you can use these sensors and get data and do some analytics through these IoT interfaces, right? So this is what I want to say about that. And then let's move on. And I have presented two more examples from the smart city. So this is the future, but not really the future. It is happening now. Smart. Now this term smart also very much connected with the IoT. No, right? Now you must have heard about smart governance, smart education, right? One aspect of the smart is IoT, right? It's AI and IoT mostly, and we can use, see the things like the smart street lights, right? And these we can control the emission levels, right? And the waste management. See, so these kind of things are really important. So this can improve our lives. IoT can improve our lives, right? You know, it's the what you need to know is how to manage the sensors, how to communicate with the sensors, and how to acquire all the data to a central interface, and then develop applications or apps or models to manage the data, right? So this is the industry for we simply an IoT application, right? Managing the whole industrial applications, right? Factories to vehicles to everything happening out there in the industry through IoT. And with after getting the data, we can perform things like that data analytics, right? Big data analytics, and even robotics. The second technology that we discuss in this section can also be considered as an example of IoT, right? Because if you look at a robot, there are a lot of sensors installed, imaging sensors, GPSs, and it can be managed through a mobile interface from a phone. So all these things, considered, robots are also an IoT application. So all these areas are related. So, right, so that's what you need to understand. Therefore, the key components of IoT, right? To build an IoT system, anyone can do that. So this is your future, right? I mean, science is interdisciplinary now. You can't just learn chemistry only, physics only, right? You should know these things as well. All these six technologies you will have to use, right, during the degree program, right? And so once we have sensor or sensors, right? So that is the main one, as a device or sensors or and sensors. So this could be, device could be a car or even animal, right? It could be human, right? And then the sensor will send the data to a controller, right? Usually these are, microcontrollers. So we need microcontrollers, right? The popular ones are, Raspberry Pi, right? Raspberry Pi kind of, microcontrollers, you know, Node NCUs, right? And those kind of, uh, you know, microcontrollers. Okay. Uh, those kind of the microcontrollers are, quite popular. So many other controllers as well, right? And then there can be gateway, to send the information to the internet. Now, when it comes to internet, we need to store this data, right? We need to store this data and provide the communication services. So, and also do the computations. So, to this, the whole thing, we need to have the communication as well, right? Gateway could be the communication, and we need to have these cloud services. The examples are we have the Google Cloud, we have the Amazon, right? Amazon Web Services. Those kind of services can be used. Uh, and in addition to these, both these things, the user interface and the clouds, these two together can be a single service that is called an IoT framework, right? So that is called an IoT framework, right? There are some IoT frameworks available for us, right? There are IoT frameworks out there. One example is popular one called ThinkSpeak, right? ThinkSpeak is a popular IoT one, and we have the Google IoT Core and the Amazon IoT versions, and all those things are there, and the cloud and the interface. So those are connectivity, can also be called communication. So these are the five components of an IoT system, right? So this could be, or even actually both together can be called as an IoT framework. So these are the main components of an IoT system. Then the popular sensors I have listed here, measuring alcohol, ultrasonic sensors, IRT optical sensors, LDR sensors, gas sensors, gyroscope, detecting rain, SenseHat, photodiode. These proximity sensors are important, and so on. So these are some popular sensors that are out there that you can use to extract data. But sensors can include even the cameras to take photos, right? Can include cameras, sound detectors like the sonar, right? Including those, right? Including those, everything as a whole can be called as sensors. So these are the popular sensors that we can use, right? And some of the popular IoT applications I have listed here, in addition to those cities. So healthcare, if I talk healthcare a little bit further, And in healthcare, we have this something called smart health, right? Smart health is one of the common application is the remote patient management, right? Remote patient management, where the particular patient, can wear, uh, some kind of a, uh, wearable device like this, right? Some kind of wearing various wearable devices, right? They can wear it, right? So they can wear these devices, and some of them even could be the biosensors, as some of them. One important application is elderly fall detection, falling, right? Falling of elders, you know, elderly, falling or fall detection, right? Did for That's an important application, uh, right? And also there are basic healthcare, right? Basic uh, care, can be managed through these wearable sensors. So that is one aspect of smart health, but it is not limited to that. We can manage the patients while they're at the hospital, right? And their relatives can be located remotely, but they can show what is happening to the patient. Uh, and there are many others, right? The earthquake detection. So these things are radiation detection, smartphone detection, even, right? So regarding this now already, we have various in Apple, even in Samsung, there are the various devices already included for this detection purposes. Water flow monitoring, traffic monitoring, right? Smart door locks, robots and drones we discussed, is security. So these are also very important, right? Even we can get the assistance of CCTV, plus the IoT can do a great job in security. Biochip transponders, and see this, part of the smart health, right? Monitoring the patient conditions. So these are some very interesting applications. And finally, agriculture and the industry applications. So these are modern IoT applications I have listed here to show how important these IoT systems are, right? And then I have included two examples. One, using biosensors for smart food traceability system, right? Uh, for food safety and security. For example, detecting, food additives, right? We can use biosensors. So this is another, application I have selected from the biology, and from science, right? We can detect plant diseases, right? Control of crops, food, pathogens, and so on, right? So this is a very, very important application area, right? So you can do research in this area. You can build, devices, do experiments. Doesn't matter you are coming from chemistry or physics or any other area. Especially the physics. So those who are planning to take physics here, you will have to use the IoT one way or the other, right? Definitely this. using sensors and programming, definitely, will be an application, right? And then that biodiversity example I was talking about uh, is connect. I have added a picture here, right? So this is what I explained. So this giraffe and elephant wearing, wearing a wearable device and various. We can identify habitats, right? Weather monitoring, animal tracking. So this is really crucial. Visual and thermal imaging technologies. Now in Sri Lanka, this elephant problem is serious problem, and this is one of the solutions that we can try, right? One of the solution to the elephant problem, and so that and acoustic monitoring also critical, and then we have drones monitoring heart rate of these animals. So like that, we can do smart wildlife or biodiversity conversation, right? Conservation, sorry, conservation. Right. So those are the applications of IoT. Very important area. So that's the third technology. Right. Now let's move on to the fourth technology. It's another important and exciting technology. So that is augmented reality and virtual reality. Right. So we are living in a world where full of these AR and VR devices, right? There are many devices, coming into the market, right? But some devices are still at the experimental level. They are just publishing ads and so on. But we are very close. We are very close to get these devices into our hands. Augmented reality and virtual reality. So let's look at an example of the virtual reality and the augmented reality. If I start with the virtual reality, as the name implies, virtual reality. So it's about creating virtual environments, right? Using graphics, computer vision, right? And we can travel through those environments and get the experience just like that we go there, right? And for example, if you anyone has not been to Singharaja forest, right, anyone has not been to Singharaja, and we can create a virtual Singharaja, right? We can take pictures of Singharaja and use techniques to convert them to a virtual, it could be graphical or highly realistic images, right? This virtual Singharaja. So how useful can that be? I mean, well, now you are going to take biology as a subject, right? And you have not been to Singharaja, but there are field trips, of course. But you know, by going there is the best option. But in the worst case, if there are virtual Singharajas, right? Of course, you need the virtual reality headset to go there. But uh, to get the real experience, but it can help your education, right? And then we can wear these kind of VR headsets, right? These kind of VR headsets, and experience a real Singaraja, right? Experience a real Singaraja, right? Uh, through this, right? So that is called the, virtual reality, right? Real like, Singaraja. So that is an important application, right? And then the other side of the virtual reality is the augmented reality, right? It's augmented reality. Now here, in augmented reality, uh, one additional thing happens is we can experience and also we can interact, right? Use interactions. And we can use hand gestures. We can, just swiping, and then even, these kind of finger movements, and then we can, go there and, interact with the virtual environment, right? With the using, right? And also, and now say you are in the classroom. Now you are learning Singaraj in the classroom, right? Learning Singaraj, right? Assume that learning about Singaraj in the class, right? Example, you know, and then a teacher can have, two options. Completely virtual system you can wear and, get the experience, right? Usually, through the head movements you can, you know go to, certain places of the virtual environment, but that's a kind of fixed virtual environment that you will be getting. But if you wear AR glasses, right, to AR device, you can assume that, the Singaraj is in your classroom, right? We can bring Singaraj into the classroom, right? Right. AR can bring Singaraj to the classroom, and then through the, user interactions, then you can experience. You can touch the animals, touch the trees, right? And then interact with it through gestures. So that is the augmented reality, right? So you augment it into the real environment, right? Augment it to the real world. So that is the VR AR, difference. Now, what this person is doing, AR. Now he's wearing, some AR glasses. No, actually, the picture that you are looking at, this person is wearing these glasses are AR glasses. And through interactions, now he's looking at a map, right? So looking at a map, and this is the map of that particular area, right? So this is, bringing uh, the virtual map into the real location, right? So this is the virtual map of the real location, and then he's interacting with, and we can interact with, right? So that is an example of AR. right? So therefore, augmented reality is an interactive experience that enhances the real world with computer-generated perceptual information. So we are in the real world, and from the real world we can experience you know that for example, this look at this some kind of uh, cooking video. Let's look at this video now, right? Right. So right, if you look at this video now, you can see that you are wearing an AR glass and cooking, and while cooking, it detects the objects and provides suggestions. Okay, you now add salt, right? Now add this, that. So this can be used to learn cooking, right? So this can be used to learn cooking. So link is there. You can once lights up. Which suggest spoons of so something like that. So it can interact, can give you know computer generated perceptual information. So this is very important, right? So AR and VR can help education a lot, right? We can, I mean, rather than discussing completely hypothetical, letting you to imagine a certain example environment, we can use these AR, VR glasses and let them interact with it, and also learn from it, right? Learn through suggestions, and the recommendations from those. So that is the augmented reality, right? And then the virtual reality is the use of simple use of computer modeling and simulation that enables a person to interact with the artificial and three-dimensional visual and sensory environment. And so here he's wearing this, and he's wearing a VR headset, right? So this is called a VR headset, and uh, and with VR we can have these kind of gadgets, right? For some kind of interactions, right? And then his experience, how astronauts might use the virtual reality in the future. Now, if you want to become an astronaut, say, I mean, becoming an astronaut is a different thing, but if you want to get that, learning, right? I mean, we can use AR, VR, and get that experience. So how important that can be. So that is the VR, right? So basically, VR generates, computer generated, environments, right? And you can get the experience by, walking through that, 3D environment, right? Okay, so VR creates an immersive virtual environment, and AR augments it into the real world scene, right? That is the difference between AR and VR. So please understand that, right? So AR just create some kind of virtual environment, and while the AR can augment it to the real world. That means look at that map example, right? You are in the actual street and you are wearing an AR glass and you see the map from the AR glass, kind of a virtual display, right? And then we have the mixed reality, the mixture of both, right? Mixture of both, blend of physical and digital worlds. So in mixed reality, we have completely virtual environments and also AR components also they have, right? So I have presented a link so you can watch this clip later, right? So talking about some popular AR VR headsets. So these headsets are from Meta, that is formerly Facebook. So they are working on this Meta Quest series, right? Meta Quest series, AR VR sets, and the app. This is the Apple's one. So Apple Vision Pro, and then the Sony has its PlayStation VR too. So these are popular AR VR headsets, and in addition we have smart glasses. This is the Fusion. Now this is Meta. Actually, they are collaborating with the Ray-Ban and producing the smart glasses. And this is the latest one. Google's Android XR, right? This is an AR. Or now we call them smart glass because here we have both actually you know types, right? So we have both types of AR, VR, and in mixed reality, and all these things are combined. Therefore, these are called smart glasses, right? In smart AR glasses, these are the most popular ones. Meta Ray-Ban smart glasses, and we have the X-Real AR glasses, and this is the latest one, Google Android XR, and this is an example from the recent launch of Google Android XR, right? So when you wear these AR glasses, so smart glasses, and walk down a street, and it can give directions, right? See, you see these things through the glasses. You can see the directions, and then it can, tell you about where is the nearest locations, right? Nearest locations, and many others. So let's look at a video of this the Android XR, right? So this is Android XR, and just to get an idea of what's happening with this now.
Or connect and create in new ways. Now, I'm going to show
Now
you
this
guys
lady
a
is
first
walking now.
2 minute introduction
Now
video by
she's
Google, and then
wearing
we can get into some of the
these devices. Now see, on her display, virtual display, she can see some recommendation, product recommendations. Now this is the AR, right? We are using a virtual environment, and we have integrated into a real environment, right? And
really cool features, because this is probably going to be
right,
how you
and
actually use AI on a
you
day-to-day
see, the
basis
important
in
thing is
media,
now, these are
how
not like
you
that
can get into some of the
big headsets. So
because
this is
this is probably going to be
simple,
how you
glasses
actually
that see you can wear, with the features of an normal glass, and it can provide various gadgets fit into the frame, and you can touch, and also you can use your hands to do various signals, right?
use AI.
uh, and so let's look at some couple of other examples
Ready
of,
work rate.
Glasses.
right
Listen till
now,
January 1st. This Monday, December 2nd. Start small with a chair workout plan for men over 50. These
right?
all-day products that you use to get value.
With glasses, you'll feel like you're alone. Really marry each other's
And
strength to bring the best
now,
solution.
Key areas that actually
if we look at some other
immediately see what's
examples,
up on your heads-up display and navigate
다음 분.
This person.
안녕하세요. 무엇을 주문하시겠습니까?
Now here, look at this. Now this is an important application for us. Now this we are in Korea now. This person speaking in Korean, and if you do not understand, then it can give you
안녕하세요.
translate to
무엇을
Korean, and
주문하시겠습니까?
it will give a translation. So how nice that can be, right? Even the Google Translation is plugged into this one, right? It is part of the these Android XR glasses, and
네, 16불입니다.
right, and also it will translate English to Korean. It will communication, both way communication. Right? It understands Korean and then it will translate back to Korean. So how wonderful that is! I mean, right? How wonderful that is. So that's another example presented here, and now see this. This is he's fixing kind of floating shelves, and it guides you with the instructions, right? So like that, there are a lot of applications, and the important part of these kind of devices is the cost, right? Is the price of these glasses should be affordable. So that is the challenge, right? That is the challenge, for all these companies to come up with affordable these smart glasses, right? So this is what smart glasses can do, right? So please remember this term smart glasses, okay? And then main components of AR, smart glasses, and hardware wise, we need smart glasses or AR glasses tablets, and then we need sensors and cameras, right, to detect the real world objects and environment. Now this is where we need the help of computer vision, right? So we need to detect these objects, right? And we need a display, that means a virtual display, overlay virtual content, right? Screens and holograms, right? So we need to generate virtual overlay content, right? And manage real-time calculations. So all these recommendation detection should be real time. That Korean to English translation, it should be real time, right? And when it comes to software, we have this augmented reality SDKs, and we have AR Core from Google, AR Kit from Apple, right? Vuforia, right? And we need the help of computer vision models and other techniques I have listed here. So these are the main components of AR. And then the main components of VR are VR headsets, right? This Oculus Rift, HTC Vive, Valve Index. So those kind of special VR headsets that we need. As input devices, we need controllers, gloves, and motion trackers, right? And then the various sensors you need, right, to get the various information, and so just like that SDKs of AR, so we need the VR engines like Unity, Unreal engines, right, and various other techniques. So in VR, we create 3D models, simulations, and the virtual environments, right? So I have added this information for your knowledge, right? And just to bring out these important features of AR, I'm again going back to AR. So this AR covers Apple AR Kit, the comparison, right? So these are the most important features. So we track the world. We need to track images, right? We need to track the face, geo tracking, body tracking, plane detection, depth analysis. So we need to have depth analysis, object detection, shared AR meshing with LiDAR, right? So these are important features of AR cores and AR kits. And all these are computer vision features, right? So we learn these things in computer vision, uh, right? You can learn if you follow computer science here, right? We have a separate course called computer vision, right? So these are coming from computer vision, right? So therefore, this AR and VR is actually kind of a combination of computer vision and also computer graphics, right? Computer, graphics. So implementation wise, we need to learn computer vision and the computer graphics. And AR, VR, as I mentioned, can be used in many areas like this. And now I have listed, some areas with pictures here. So for medical education, now you can wear AR, VR headset or glasses and, learn with it, right? For medical education, because we might not have the human or human subjects or animal subjects all the time, right? So we can get the help of AR, VR, and military training, right? So military training, it is difficult to create, real military setups for everything outside. Then we can use AR, VR for that. And of course, shopping and retail is very clear, right? Through the phone app, we can uh, get the information about various products and the guidance, recommendations, and we can use it for interior design, right? We can, show the actual design, how it is going to look like, right? We can project it in the actual environment, right? And of course, for entertainment, now this is a scene from the Iron Man, if you have seen, repair and maintenance free, even, before doing the real, digging into the job, we can wear these AR glasses and, get all the information and then start the job and also the industry. So like that, there are very, very interesting applications out there, very important technology, and especially education, right? So these things will come. I mean, we are in the age of AI, age of these wonderful technological enhancements, and you will see these things in the coming years, right? So that is the important part. And then the Meta or the Facebook is creating this, metaverse environment, which is hypothetical iteration of the internet as a single universal immersive virtual world. Now the internet is, we log into web browsers, type the URL, and get into the internet. Now in the future we can wear these smart glasses and live in the metaverse, right? Live in the metaverse. We can do shopping, education, uh, you know all other experience, we can obtain through the metaverse, right? So that is, they are one of the meta projects going on now. This is a virtual shop that we can, buy clothes, right? Now, just a web page that we can, add whatever we want to the cart. And with AR, VR, we can try virtual fit-ons, and then we can do the shopping like actually walking in the actual place, right? In the actual, place. And this could be one of the shopping malls in Colombo, right? Shopping malls, Colombo, Kandy, or anywhere, and they have their own websites, right? Or those shops have their own websites, but if they can bring in AR to their websites, and they can bring the clothing store, the entire store, into the virtual world, and then you can do the shopping just like walking through their environment, right? And we can, buy and we can try virtually, and then, complete our jobs, right? Okay. Then how to become an AR and VR developer? The first thing you need to know is to learn the programming languages and hardware, and you must know 3D modeling, and you can learn the video game development, right? Learn user experience. So this is called the UX, it's a separate area, and of course, the all important computer vision and deep learning, machine learning. And importantly, you have to have a kind of a designer mindset to become an expert in AR or become an AR VR developer. So this is an area is open for anyone, right? If you have a good designer mindset, learn these technologies, not a big thing, right? Not a big thing to learn this, and then you can become an AR VR developer. Okay. So that concludes the technology number 4. So the remaining technologies are cloud and the VR. So before going there, let's take a break and continue. It's 11:14. I will resume at 11:20. Well, let's take a 5-minute break. Okay, let's resume. I hope all you are still there. And the fifth technology that we are going to learn is the cloud computing. Now, this is a technology that you have already got the chance of experiencing, right? So that is your Google email. Now, one example of cloud computing is this your email. Now we have this email system side.pdn, right? We have this side.pdn email system. Now all of you got an email address. Now this is actually a Google email, right? This is Gmail, right? Now, Google email services, as you know, Gmail. Right? Actually, you have been given a Google Workspace account, right? So you have something called Google Workspace. That is a cloud service, right? This is actually cloud service. It's not just a Gmail account, so it has other features also, right? With available with the with this Google Cloud Space, and including the storage. So you have the Gmail, and you go to storage, and other apps, including docs, sheets, right, slides, right, and also calendar, right, and so on, right. So, right, you have been given a Google service account. Now, let's use this example to understand the cloud computing, right. Right now, you have this CIPDN email address from Google, right? CIPDN uh, Google Space account, right? Google Workspace account. So let's use this as an example, right? Now, this is managed by Google, right? This is not managed by us, managed by Google. But we are also managing the certain component, right? That is the email creation and all those things we are managing, right? So what is managed by Google is the hardware, the servers. Now, to provide an email address or whatever workspace account, there should be servers, right? So this hardware means servers, right? So hardware means servers. So this is managed by Google. So that means we have not seen this hardware, and right? And we are just managing, right? We are managing the services, managing or administering the service, right? The services, right? So this is a classic example of the cloud, and that means we are accessing the hardware through the internet, right? We are managing these two through internet. We are managing it through the internet. right? So that's a classic example of, cloud computing, providing resources via the internet, right? Virtually, right? These are virtual resources, right? So other, option is if you have, uh, our own, email servers and so on. So that is called on premises, right? On premises, hardware and software, right? On premises means, we have to handle everything, right? We have to handle everything. That means both hardware and software. So we have to have actual servers, and also we have to have email software. Also, storage supporting software, right? Hardware and software, right? So it should be our own servers, our own servers and software. So that is the difference. So our Google Workspace accounts are coming from a cloud. So we're accessing through the internet, right? But if we had our servers, so we have to manage the operating systems, the storage, the other software applications. So that is called the on premises. So that is the difference between on premises and cloud. So with that, let's go to the definition. So the cloud computing is on demand availability. It's actually availability is on demand. Okay. In fact, the University of Peradeniya should pay, right? Actually, we have been given 100 terabytes for free, right? So we have to manage everything within the 100 terabyte storage, right? And then because for each account, we have to allocate some space, right? And therefore, we have to manage smartly these 100 terabytes. And if you want to increase that, we need to pay, right? So that is on demand availability of computer system resources, especially data storage or cloud storage and computing power via internet. So we are actually getting computing power. So we don't have to have our own computers, right? So that means if you want to start a new company, new institute, you don't have to worry about the computers much, right? The only thing you need to have is some basic, computers, and we can, get the email services storage capacity from the cloud, right? So that is the definition of cloud computing. So this is the on-premises versus cloud, the advantages of cloud, right? So on-premises versus cloud, right? On-premises means having our own hardware and software, as I mentioned earlier. And with the, on-premises, scalability is an issue. In the cloud, scalability is not an issue, right? Scalability wise, so we can add any number of users, any number of, computers we can buy through the cloud, right? So another advantage of a cloud is the storage, right? When it comes to storage, having our own storage can be expensive, right? So we have to buy storage and we have to manage it. And we need, technical experts, right? We need to have, so many network managers to handle our own, storage. But the server storage we can use, Microsoft Azure, Amazon AWS, or Google Cloud Computing Platform. So that's another advantage of cloud computing. And the other aspect is the security. So security, if we have our own devices, we have to implement the security system, right? We have to have password management, cryptography algorithms, all those things we have to implement. Of course, we can get the support from other existing tools, but still we have to do the management. Basically, with the cloud computing, we can get the support of their existing security systems, which are generally well designed and very powerful, right? So that is those are some advantages of using cloud. Having said that, in a university or in a hospital, we have to have some on premises devices, right? So we need to note that actually we have to have uh, some on-premises devices, right? Because for example, in a university, to manage results, right, grades, that's the key information in the in a university system. So we have to have on-premises devices for that, right? Example, resource management, right? Maybe some kind of patient, not all, some very special patient management in a hospital. For those things, we need on-premise devices, right? Please remember that. Even though we say that cloud services are better, but still remember we need to go with kind of a therefore we can go hybrid. We can go hybrid, but more towards uh, cloud. So we can have like 70-30, 70% cloud, 30% our own servers, right? So we can go hybrid. So the main cloud service providers, I have listed four of them. Of course, the Google is everywhere, right? Google Cloud Platform, or GCP, Amazon AWS, Microsoft Azure, Oracle Cloud. So I have listed four main cloud service providers, right? So these providers provide this service in three, packages, right? They have three types of, cloud services. Yeah, before that is that hybrid idea I was mentioning. So we can go for kind of a both public and private, right? Kind of a hybrid cloud we can go. And this is what I was mentioning. In terms of providing the service, there are three types of services that we can obtain: uh, IaaS, PaaS, and SaaS, right? That means infrastructure as a service, platform as a service, software as a service. And what we are using in the university is a kind of platform as a service, right? This is our Google Workspace, right? Workspace at UOP is a platform as well, because we are using application and data from the cloud, but the runtime, the middleware, operating system, and all those things are managed by the provider, right? So the green ones should be managed by the customer, and the red ones managed by the provider, the cloud service provider, right? So since we manage some kind of storage and we run some applications, we are using, it's a kind of platform. Actually, it's again a kind of hybrid. Both PAs and SAS services are there. The other ones are infrastructure as a service, where we have to manage the applications, its data, runtime, middleware, or even operating system, right? We have to take care of the operating system also. That is, we are managing the infrastructure, right? infrastructure, and the platform we are managing applications and data only. Why? Because you know then why? Reason that we are using only a platform as a service is because we have our own servers as well, right? We have our own servers also, right? And then software as a service is we just use their software. I mean, here, if we just use their Google Docs, sheets, and slides, then that means we are using software as a service. So we are actually, as individuals, we are using this as individuals. That means our personal Google accounts, right? Not the university one. Personal Google accounts, if you have, are software as a service because we are using the Google Docs, their calendar, right? Google Sheets, Forms, right? So all these are software, right? We don't have to manage their storage or any other. We don't write applications on top of that. So therefore, we are using SSAs, right? So that is the software as a service. And if you run on premises, you have to handle everything, right? We have to handle everything. We handle everything, right? And then in the next two slides, I have explained it, right? What do you mean by SaaS, right? So we just use their software, IaaS. That means we manage, some level of a middleware operating system, right? So there we can use the Google Compute Engine, AWS, Elastic, you know, servers, and the DigitalOcean, Microsoft Azure, and the platform as a service. This is what we are doing actually. We are using Google App Engine. This is handled by the university network unit. And these are the other platform as a service options that we have. So, but we are using this one, and few Google apps are there. And for example, your email account, there is an interface. You added your data, so that was done using one of the Google apps that we have developed, right? And then talking about the cloud storage, I have listed some popular cloud storages. Now with your Google account, you have the Google Drive, and we have Dropbox, OneDrive. All these systems, they provide some level of free storage, like 15 GB, 5 GB, like that. But if you want to increase it, then you have to pay, right? So actually, they are doing a business. So these are called cloud storages, right? It's a model of computer data storage in which digital data is stored in logical pools, right? So with your university Google account, you got some storage from the Google Drive, right? And I will show you one example only with the Google you know cloud engine. Now this is their website, the Google Cloud, and if you click on their products, actually it's a big system. I mean, in the if entire Google Cloud, it has support for AI, machine learning, data analytics, even the large language models. We have the Gemini, uh, right? And we have various databases, right? AI and machine learning, business computing, right? And networking related, tools, right? Management tools and everything is included. It's a very big system, right? It's a comprehensive, massive system that provides these things. under the Google Cloud. So if you search on Amazon AWS and Microsoft Azure, you will get similar details, right? And these are the advantages of cloud. We discussed this earlier, right? So that is the fifth technology. And out of those six must-know technologies, the last one I have selected as blockchain. So this blockchain originally uh, proposed as a kind of a cryptocurrency system, but it was later extended to some kind of a data and security management service, right? So it's a powerful concept. So let's look at a small video clip and come back just to get some idea about one of the you know YouTubers explaining the power of the YouTube and its uh, applications.
Transform your everyday
Right?
life, and it's starting right now. Even though blockchain technology came into existence with Bitcoin, blockchain
So
has
it came
a
into
reaching potential
existence
with
with
Bitcoin.
this one of the popular cryptocurrency called the Bitcoin. So we can manage money over the internet securely. Money means we need a lot of security. So these are kind of virtual, money. So when we buy a Bitcoin and it ours. Now, if you buy a Bitcoin, it should be yours, right? And you should have that guarantee. And this whoever the service provider should make sure that no one else will share the same Bitcoin, right? So they are the idea of this the shared data, right? This is blockchain manages shared data, right? You can even think of uh, a shared Google Doc as one of the blocks in the it's a chain of blocks. You can assume Google Doc as even a chain of blocks which is cannot be deleted, right? So that cannot be deleted, but the advantage of Google Docs is everyone can see it. So when you purchase a Bitcoin, that everyone can see that it's your Bitcoin, right? But in blockchain, the same technology is used in the blockchains to manage various data sharing, the security, right? And the various processes, right? Supply chains to manage processes, document management they have used, right? But came to the existence with the Bitcoin. So that is the first thing I want to highlight here.
Blockchain has a far-reaching potential outside of cryptocurrency.
And these are the blocks. Now you can
Blockchain is a
see
shared
these are kind of virtual, but these blocks has some data about now if you say you want to sign a document, right, in a group now. Say you have formed a company and the whole the legal procedure you have to follow. And let's say there are five people you have to sign, right? The same document should be signed by five people. And if you do this digitally, you have to make sure that all five people have signed the document. And when one person signed the document, other five will see it, right? Other five will see that the one person has signed, and once all the five people sign the document, transaction will be completed, right? So blockchain means that when one person signs, that the data belongs to one person, right? One block, and then you create a chain of blocks with five verifications of the document signing or signatures, and then once the chain is completed, the transaction is successful. It's a technology like this. The important thing is that no one can edit the data. No one can change the data in these blocks. right? It is ensured through cryptography, right? So it's a shared database, right? Shared database. You can share documents, transactions, contracts in this database, right?
Shared database that allows multiple parties to access data and verify that data in real time.
Right?
It
Where the this is multiple parties accessing the same data, like signing a contract, even the money that cryptocurrency, right? It could be a supply chain where you want to make sure that from the say delivery of vegetable from the farmers to the final destination, supermarket, the whole supply chain is there, and you have to make sure that everyone got involved. There are not cheating in between, right? And then you got the vegetable exactly as the original, location, right? So to make sure that all parties agree, because all parties can see that any change, right? So that kind of things can be handled through the blockchain, and then later this person go and describe about the application. So one major player that can use blockchain, this even our government can do that, the government, because government manages the legal procedures, the policies, right? And they need to ensure security, the food safety, various kind of safety of the people, right? The security, and all these things involve data, and the government can use blockchain and make sure that all it's transparent. Government must make sure that the procedures are transparent, right? One of the things that we can do is the voting. So digital voting, it should be one of the things that people must see the transparency, right? You should see that its voting procedure is perfect and there are no violations in between. So to do that, we can digitalize the whole process and use blockchain to protect it, right? And the important thing is, no one, your vote, we can give digital ID and no one can enter and regenerate, or no one can generate fake votes, right? No one can generate fake votes. Those kind of applications can be done, right? So digital voting, and then we can use it for transparent budgeting, record management, right? So we can manage records. uh, Budgeting means various procedures, procurement procedures, all those things we can use blockchain, right? I will share these links of these videos on the LMs, right? So then in the slides I have defined it. So it's a decentralized database technology designed to provide a secure and unchangeable record transactions, right? This is the two key terms. It's a service that makes sure secure and unchangeable record transactions. So this will be our future, right? You will see this blockchain is used for many processes where secure transactions should be guaranteed. For such processes, we can use the blockchain, right? And it's a distributed, decentralized, what we call the digital ledger, right? We call it a digital ledger, right? That records transaction across multiple computers, right? It records transaction across multiple computers. So that is the definition of blockchain. And this is the simple analogy, right? You can think of it as a shared Google Doc where everyone has access to the Google Doc. And when someone makes a new change, everyone sees it. That's the transparency. right? And no one can erase the old changes. So changes cannot be erased. And it's like super safe notebook that everyone watches together, right? So that's a simple way of understanding blockchain, right? Think of it as a shared Google Doc among many parties, right? Right. So this is again further definitions, and this is how it works. Now, if you want to have a kind of a transaction, right? And what we need to create is we create a block representing the transaction, right? When all the detail. For example, you can assume signing a document, legal document, right? So you want to purchase, say, you want to purchase a land, right? You want to purchase a land, and then when you buy it, you pay it, and when you buy it, and the land deed and the other document should be transferred to you, right? So now you buy the land, you sign the legal documents, and that's the block. That is the block, right? And so that block contained all the transaction, details, and also there is a process to manage these the legal procedures, and you can make sure that a chain of blocks can are there, right, going through each space, and then you make sure that uh, all the blocks are there, and each block is verified, and the process is complete, right? So you create a block, and then this block will be shared among all entities, right? All the parties involved in this land deed, uh, mm, and this block will be shared among them, right? Block will be shared among them, and then number four is this: we validate this one, right? We validate, and then we create a chain of block, and then at the end we have the success, right? So we have the chain. This is a chain, and this is the last step, right? If it is validated, right, last step, last transaction. If it is validated, process complete. Now the process is complete, right? Now the process is complete. So that's how blockchain works. So then I have used that, property deed example, right? Every transaction, owner transfer gets recorded permanently, right? And everyone can see that you are the new owner, and no one can secretly change it. So this is very, very effective technique to manage legal documents. So what we do is nowadays is use paper-based documents so that we can misplace them, and then we can prove that it's our land. And if you digitize everything, and then we can protect our deeds and any other legal document using blockchain, right? And so these are the details about that, right? These are details about that, right? And then I have listed some applications of the blockchain broadly. Now we can use where there is supply chain, right? In supply chain management and logistics, and we can use to manage, healthcare, health documents, or doctor referral procedures, the patient, care, procedure. And of course, this is where it started. The cryptocurrency was there, and handling contracts, smart contracts, providing financial services, voting that we discussed, land registration, artist royalty. So this is for the musicians and the movie directors. Once you create your own whatever the song or any document, this intellectual property management, right? So you can manage intellectual properties. So once you put the song with a digital ID and in a blockchain, everyone can see that it's your song. No one can change it, right? So, so that how it goes with the applications of blockchain, right? So with that, the section two of sorry, section two. Sorry. So with this, the second part of the section two, six mass node technology, uh, you know, is completed now, right? So we have completed and we have discussed all the technologies, six technologies: artificial intelligence, robotics, Internet of Things, AR, VR, cloud computing, and blockchain. So this is our must-know technologies. So this is our future, right? You will have to use these technologies during your degree program as well. So we are going to a digital world. So we have transformed digitally, and the knowledge about these things will be quite essential in order to make good progress, right? So please remember that. And I will have my third session on Friday, which will be on using AI, right? Uh, effectively and also responsibly. When you use AI, you have to be responsible as well uh, to improve your education. Starting with note preparation. What are the good prompts you can use, and summarization. Prepare before the lecture, and have kind of a discussion, and all those things can be uh, you know discussed in that session on Friday. So I will end the session. So the slides and the video will be available now. I have uploaded the slides of the part one and the recording of the same part one. And please watch the video and get notes. And this is a course. Now remember, the attendance is very poor, right? That I will report to the course coordinator and the other parties. And please remember, this is a serious, course. 2 credit will be considered for the GPA, and so you have to take this seriously, right? You have to take this course seriously. And next time, I will post, some kind of an assignment that will be considered for the final evaluation as well. Therefore, I expect much better attendance for my Friday session. So this is not acceptable, cannot be acceptable, right? I mean, this is very bad situation. Only half of the batch is here, right? We cannot let this to continue, right? Actually, I don't want to spend time in the at the beginning of the session. Otherwise, I will run out of time. Otherwise, I would have given some kind of an message regarding this attendance issue. But please remember, the attendance is important. Now, I will use the attendance of these two sessions. I will download from Zoom. We can download who were there in the session, and then we'll consider about adding marks for the attendance as well. Right? We'll consider adding marks for the attendance, and don't take this course as too easy. Right? I have seen that those who have some computer background end up performing poorly. Right? Those who did not have much background, right? Had